Hi everyone. In this video, I'd actually like to do a little work on continuity. So we have established that in order for a function to be continuous, the function has to have a y value and the limit has to exist at whatever x value we're asking about, and the y value has to match up with the limit. So that's what we're going with. We already have a pretty good idea of continuity, so that's really just about formalizing it a little bit. But here, to actually practice and make sure we're good with our continuity, and this ties back into our limits nicely, we want to see if we can find the value of any constants in these piecewise functions that I've come up with that would make the functions continuous. So this first function is defined in two pieces. Piece number one is a rational function, and actually one we've seen already today, I believe, already in these videos, I believe. This piece of the function will only be used if x is not equal to negative, oh, I knew there was problems with signs somewhere. Let's make these positive 2's. That's more like it. Okay, so if x does not equal 2, then this is what the equation will be. If x does equal 2, then we get to choose some constant value k to put wherever we want. So we know its x value is 2. We get to pick its y value. This is basically just a point. We get to place a single point, and the question is, can you place that point so that this function will be continuous? It's definitely not continuous right now, not just because we said x can't equal 2, but even if we didn't say it, there's a problem at 2. So we want to think about what's really going on with the graph here. And this is one of those nice ones where if we look at that top piece, that's an x plus 2, x minus 2, divided by an x minus 2. This is a removable discontinuity. So basically, this is equal to x plus 2 as long as we don't let x equal 2, which means the graph of just piece number 1 is really just the graph of y equals x plus 2 with a hole at 2, 4. Okay, so here's the function we're working with. Pretend that looks like a straight line. It's looking rather curved from here. Okay, so the question was, can you place a single point with an x-coordinate of 2 so that it makes your function continuous? And the answer is absolutely. If I place it at 2, 4, it would fill in the hole and I would have a continuous function, which means that k has to be 4. The x-coordinate of my hole is given, or of my point. The y-coordinate is up to me. I choose that the y-coordinate will be 4. Okay, so that's the idea with these problems. I have 2 more for you, so let's keep trudging through. This next one, I get p of x equals x minus 4 over x minus 2. And once again, these are supposed to be pluses. I was looking for this when I was editing, but I thought it was in your homework. And then I get to place another point. So I get to choose the y-coordinate of the point. The x-coordinate has to be 2. So we're looking for the value of the y-coordinate. So again, I think this is about, do you understand what's going on with these functions? So if I'm looking at y equals x minus 4 over x minus 2, this one has me a little more worried because when x equals 2, I get negative 2 over 0, which is not a hole in the graph. That's asymptotic behavior. So I have a vertical asymptote at x equals 2. Let's see, I can even figure out what this looks like. You could check with technology, but I think I can do it fairly quickly. So this is 2, 1, and it crosses the x-axis at 4. Okay, so this is a quick sketch of this function. That's what my function, that's what piece number 1 of my function looks like. And the question is, can you place a single point with an x-coordinate of 2 in a way that makes this function continuous? And the answer here is just, it's impossible. It doesn't matter where I put a point. It's not going to make this continuous. So let me see how the question was worded. Find the value of constants that make the function continuous. I'm just going to say impossible. It's not really like an undefined or it does not exist. Maybe does not exist works. Just can't possibly do it. Okay, so one last one. I'm going to modify piece number 1 a little bit. I'm going to let you choose a coefficient for x. Okay, and then we'll look at piece number 2 in a minute. And once again, make those positive 2's. Geez. Okay, so if x is 2, I'm getting that 0 in the bottom again. So I'm back to that whole thing where I am not going to be making this thing continuous unless I make sure that this is a removable discontinuity. So if I don't pick the right a value, this is going to have a vertical asymptote. So this goes back, sorry for the yawn, to the 0 over 0 thing. We already know that this is 0 when x equals 2. We would like the top to also be 0 when x equals 2. So if x is 2, we have a 2a minus 4. To make that 0, it looks like a has to be 2. So a has to be 2 in order for piece number 1 to have a removable discontinuity. So now I'm looking at 2x minus 4 over x minus 2, and I can factor that 2 out, and I get to cancel. And since this is only if x is less than 2, I don't have to worry about the x equals 2 problem. So really, by choosing a equals 2, this is getting boring with all these 2, I've just changed the top piece of this function to be y equals 2. That's all it is now. So I've just made the top a horizontal line. So if x is less than or equal to 2, then y will equal 2. Looks like this. Okay, so now I have kind of a secondary question here. Piece number 2 is y equals bx minus 4. So this is some sort of linear function, and I get to choose its slope. And the question is, can I choose its slope in a way that makes this continuous? So this function is supposed to start up when x is greater than or equal to 2. The only thing I know for sure about it is that if I went all the way back to its y-intercept would be at negative 4. I'm not supposed to, because I'm supposed to stay to the right of 2, but that's the idea. So if I want to make this piece, make the function continuous, it needs to meet up with this horizontal line that I now have. So I'm hoping to find a slope that makes it go right through that point, and then I'll just keep from there on. So we want to make sure that this line goes through the point 2, 2. So we can just plug that in. We know that when y equals 2, or you could just count it out probably as well, x has to equal 2 as well. So it looks like 6 equals 2b, or b equals 3. 3x minus 4. Okay, so I maybe made that trickier than it had to be. If you want to just count it out, this is 0, negative 4. So I go over 2, up 6, and that gives me my slope of 3 as well. That's probably the easy way to do it. So it looks like to make this line hit that horizontal line that I had, I have to choose b equals 3. Okay, so this is just a little bit of playing around with continuity. You'll see stuff like this in your homework. I think they're kind of puzzly and fun, so hopefully you have fun with them too. Thanks.